All right, so lesson 12, we are distributing expressions. And remember, let's keep in mind here, a lot of what we're doing is rewriting, whether it's simplifying, writing it in another form. So we're getting away from just simply solving and getting a number answer like we are used to. So with lesson 12, we're actually going to go ahead and we are going to bounce down to example 2. So you are going to turn your page. And we'll get started here. So we're going to kind of show you the visual approach here, and then certainly show you the algorithm just so you can make your connection. So we want to write an expression that is equivalent to doubling 3x plus 4y. So when we double something, there's a few different ways we can do it. One way is we can take what we've got, and to double it, we just simply add it all over again. All right, that will double something because double means we have 2 of them. So how can we rewrite it? Well, the other way of doubling means to, yes, multiply by 2. So we could do 2 times and then 3x plus 4y. Now let's keep in mind here, a number up against parentheses does mean to multiply. Even though we've got stuff that's going on in there, it's still a multiplication problem. So they want to know, is this expression in factored form, expanded form, or neither? It's actually in factored form. And the reason why is factors are, yes, it's what's in a multiplication problem. So like 4 times 3 equals 12. 4 and 3 are the factors. So here we're actually multiplying the 2 with 3x plus 4y. It looks different. We're not used to a factor being one number, but we don't know what this number is because we don't know what x is, we don't know what y is. So this is considered all one particular factor. This says start the same way as the first example. Since we're skipping to it, I'll give you that there. Let's draw. All right. What should we do? Let's go ahead and let's draw. So it says, how can we change the model to show 2 times 3x plus 4y? So picture-wise here, one of the things we can do is we can say, okay, we've got a 3x, and then we've got a 4y. And since we're doubling it or timesing it by 2, we've just got 2 sets of them. So we've got another 3x, and we've got another 4y. So now it's saying, are there terms that we can combine in this example? Well, yeah, actually, if we've got 3x's and 3x's, it's kind of like saying I've got $3 and another $3. Altogether, I have $6. So we actually have 6 x's that are there. And again, 4y and another 4y means we would have 8y. So again, that's your visual approach of what we've got there. What we're actually doing here is going, whoa, wait a second. I thought a number up against parentheses means to multiply. And yes, we are correct here. But look who's inside there. There are 2 people that are in there. So just make sure you multiply to everyone who's on the inside. 2 times 3x, 6x. The 2 times 4y, 8y. Since it is a plus sign, we get our plus sign in between there, and oh my goodness, looky. They are the exact same that we've got there. So, summarize, how would you solve this question without the model? The phrase here is our old friend, can you finish it?
Oh, good for you.
Yes, good for you if you said distributive property. That's what we are after here. So the distributive property is going to speed things up because we don't have to do all of our drawings to go along with it. We're able to just simply multiply. So let's get to the good stuff here. And we want you using that algorithm. So write an expression that is equivalent to 3 times 7d plus 4e. Let's jump right to it and let's use our distributive property. A number up against parentheses means to multiply, but there are 2 people that are in there, so you got to multiply them to both of them. So 3 times 7d, not 7t, 7d. So 3 times 7, 21, and we've got our d. 3 times 4e, 3 times 4 is 12, so it's 12e. Show's over. That's it. We can't add these guys together because the D stands for something and the E stands for something else. So we can think of it as we've got 21 dryers, and here we have 12 E's. Elephants. We can't add elephants and dryers together, so that's why we got to leave them separate. So let's go ahead and let's keep on moving here. It says create a model. Not worried about that. Let's write an equivalent expression using our distributive property. So 3 times x, 3x, 3 times y, 3y. That's it. We can't add these together because one's an x and one is a y. Go to the next guy. Just multiply and multiply. Go and put it down. What'd you get? Did you say 8h plus? And then did you say 4g? All right, that's what we're looking for there. Did you combine them?
Oh no!
Good, no, we can't add the h's and the g's together. The phrase here is like terms. That's the phrase you're going to start hearing more and more. Call the h something, call them horses, call them goats. When you add horses and goats together, you still have horses and goats. All right. So let's finish things off here. Go ahead and distribute. Go ahead and try. I'll start filling in my answers as well, and then you can kind of check them as we're going through them. So 8 times h, 8h, 8 times 3, 24. Now watch, we've got a plus sign. You need your plus sign in between there. Okay. Distributive property. Number up against parentheses mean to multiply. Just make sure you multiply to everyone who's in there. 3 times 2h, 6h. 3 times 7, it is 21. Keep going. Multiply, multiply. 5 times 3x, 15x. 5 times 9y, 45y. And again, we don't have like terms, x's and y's, h's and a plain old number. All right. And the last one. Did you say 44h plus, and then multiply it to the second guy, you say you're 12g. All right. Sorry about the writing here. That was kind of off a little bit. The main thing is they want you to kind of see what's going on here. Again, we're not as worried about the visual, but the whole idea here is how far is it from here to here? Well, it's 7k plus 12m. Remember, the area of a rectangle is to multiply, so j times 12m is 12mj. All right. If this is j, that's j, so and that's 7x, so 7k, excuse me, 7k times j. If you want to fill your j in so you can see it there, that's fine. We can go plus 7kj. All right, and yeah, there we go, distributive property. We multiplied them out. Again, the visual, you're not going to see it moving forward. So I'm not as worried about that. Let's look at the last one here. This is where a variable comes in, a times 9b. And again, if you want to write it out, what we've been doing, that's fine. But there's really not a need to, plus, and then a times 13. So a times 9b would be 9ab plus a times 13, 13a. Don't get any ideas of multiplying all this together because look who's there. It's an addition sign. So you can only multiply these guys. You can only multiply these guys. They're kind of the same, but not exactly. It's kind of like saying we're talking about silverware here. So is a spoon and a fork kind of alike? Well, yeah, we both use them to eat food, but they're not the exact same items that we've got there. So the distributive property is the reverse of factoring, and you should kind of see some similarities of how we're kind of going back and forth. That's it.